There we go. Keep it real, niggas think they really know me. I know the deal. Name is God, I keep it real. Niggas God, I keep it real. Nigga, niggas don't know my name. Nigga dog, nigga touch your elbow. I keep it real. I'm in the realest niggas feel this. My name is Scott Dog, and I do this shit for realest people. Hidden in them, hidden in them. My name is Scott, and I be like a riddance, nigga. Nigga, what I flow until I go. People think they really know me, man. I'm about to let them know you ain't my homie. Leave your girlfriend motherfucking lonely. Tone it, 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 tone. Leave me alone, tone it, tone. Leave me alone, that tone it, tone.
Ninja, ninja, ninja.
Yeah, I'm about to spit, I'm about to rip. People think they empty clips. My name is Scott. I rock. Go up in the club and empty out the Glock.
Ninja, ninja, ninja.
Doesn't like that. People think they know me. You ain't my homie. You can leave your girlfriend lonely. Nigga, home. Nigga, I'm in the zone. When I rip, I spit. I'm doing crazy shh. Name is Scott Dog. Nigga, name is Scott Dog. I'm a hoe. They always tell us smart contract.
The procedure that many companies follow to reach production level code is to first design the program, then code and test it in different environments, and then put it in a pipeline to deploy to production. Developers can make it pretty far into building a core application before inevitably having to include enterprise features and security standards such as single sign-on, Okta security, and authorization for different user groups, Workday integrations, and other things. These requirements can put stress on a team with newer developers or limited resources. For some large projects, these standards need months to fully build out and test. The company WorkOS is dramatically shortening the time that it takes to make applications enterprise ready so that developers and IT teams can focus on the application itself. WorkOS provides developer-minded tools like RESTful endpoints, JSON responses, framework native SDKs, and a developer dashboard, among other tools, to integrate otherwise complicated enterprise standards in just a few lines of code. Their mission is to simplify building applications for enterprise users so that developers can focus on creating core features in a timely manner. In this episode, we discuss the process of building enterprise applications, the challenges of modern security and administrative requirements, and how WorkOS is solving those issues. Creating test data in-house is a complex, never-ending chore that eats into engineering resources. With regulations and breaches on the rise, production data is no longer safe or legal for developers to use. With Tonic, you can create a mimic of production data for your developers to use in their local or QA environments. Teams no longer need to choose between productivity and security. They get both rapidly and with ease through Tonic's database subsetting, de-identification, and synthesis tools. Mathematically guarantee the privacy of your data and shorten your development cycle with realistic test data that integrates seamlessly into your development workflows. Visit tonic.ai/sedaily to learn more. That's tonic.ai/sedaily. Thanks to Tonic for being a sponsor. Michael, welcome to the show.
Thanks so much for having me.
You are working on WorkOS, which is involved in making apps enterprise ready. So we should discuss what is the difference between a application that is ready for a startup, let's say, versus an enterprise.
So there's kind of two different phases companies go through if you think about the life cycle of SaaS. First, when you get started, you're focusing on just building the core product to get what people call product market fit, to get those initial users. And when you're in that phase, you're really just focused on creating new experiences for customers that attract them in and creating a delightful experience and a great sign-up flow. At some point, if you succeed and your app gets more and more users, you'll want to deploy that app, essentially get customers at really big organizations. This is the same playbook as something like Dropbox or Slack or Airtable, all these companies. And when your app grows in usage and those bigger companies want to adopt it, there's a whole set of features and functionality that they need, which is really not your core app experience. It's actually how that app is managed at scale within that company. And it's all these adjacent features around things like authentication, security, compliance, stuff like that. And those are the features that people usually refer to as enterprise-ready features. The things that are typically in the enterprise pricing column on the SaaS apps page, and things that the IT administration is using to actually manage the app within that organization. The most common one that most people are familiar with is single sign-on, so like signing in through Okta, where you're using the identity system of the company, but there's a lot of different features like this.
Now you take the Okta example. Let's say I sell an app like, what's a good example here? Like Slack? Is Slack a good example?
Yeah, Slack's a great example.
So let's say I'm Slack and my product is getting popular. I'm selling to enterprises, and the enterprises now want me to be able to provide them a method of signing on through Okta. Isn't this kind of integration something that Okta just delivers to Slack? Like Slack can just go to the Okta webpage and figure out how to build their integration?
You can totally do that. And that's how people do it today. So if you have one customer saying, hey, we have all of our users signing in with email and password, but we really need to use our enterprise identity system, Okta, the developers at Slack in that scenario would have to go to the Okta documentation and sign up for a developer key and get it connected and configured and all of that. The problem here is it's not just Okta that's out there. There's many, many different vendors that actually provide these enterprise services that large organizations use. Okta is just one of them. In the identity space, there's also Microsoft ADFS, Azure AD, Google actually has a SAML, Google SAML implementation, Ping Identity, OneLogin, generic open source Shibboleth servers, which expose SAML endpoints. And so as a developer, you might be able to knock off one of them by just going and building with Okta, but there's this tremendous ongoing effort you have to do to actually keep adding that integration work and keep making your app work with more and more customers. And so it starts off as being like, feeling like a one-off, one or two things, actually snowballs into being a really substantial engineering and product lift. And most of these companies, if you look at like Slack's organization today, a huge number of their engineers are actually not focused on building product features for users. They're focused on all these enterprise features because at the end of the day, these are what block revenue and block deals for them going up market. So they end up getting prioritized over novel features.
Okay, now let's look at it from your point of view. If you want to build a product that makes it easier for Slack to have single sign-on, what do you give them?
So a lot of people compare WorkOS to other software middleware essentially out there, things like Plaid or Twilio. So let's take Twilio as an example, right? So if you wanted to use Twilio, or if you wanted to send SMS messages in the previous world, you would have to go to all the independent, SMS networks, all the different telcos, and build direct integrations with all of them. That would take a long time. With Twilio, you integrate once, they act as an aggregator, you send it to Twilio, and then Twilio has the integration with all those different systems. WorkOS behaves very, very similar to that, where a developer integrates with the WorkOS SSO feature, for example, and then we've actually done all the detailed work integrating with all the different identity systems that are out there. So you don't even have to know what SAML stands for. You don't even have to read, docs around ADFS or OpenID Connect or any of these things. You plug in with modern APIs and WorkOS handles it after that for you. And because we're supporting so many different applications and so many different users, nothing for us is a one-off. We've actually obsessed around this problem and fixed all these small edge cases and details. So the experience that you get by using WorkOS is essentially as if you had an entire team working on it for several years, which is what we've had.
Give me a little bit of the nitty-gritty detail of what's difficult to build in solving this kind of problem.
So there's a lot of stuff in the actual SAML spec that is, if you go read the RFC, not super well specified. Sometimes RFCs use the words like should or may instead of being really tightly specified. And what this...
Okay, that's pretty boring, right? What other podcasts do they have? Let's go to... Hold up. Okay, check this one out.
Creation Labs is helping bring Europe one step closer to fully autonomous long-haul trucking. They have developed an AI driver assistance system that retrofits any commercial vehicle, starting with Volkswagen Crafters and other trucks. Their system uses camera hardware mounted to the vehicle to capture video data that's processed with computer vision to understand the context on the road. This piece of the system was developed by the world's leading experts in computer vision. While the computer interprets what is happening on the road, data is sent to a processing system that can control the vehicle's braking, throttling, and steering. The system currently augments a driver's role, but does not replace the need for the driver yet. However, the distance between great drivers and bad drivers is around a 30% difference in fuel efficiency, according to Creation Labs. They've trained their systems with data from the best drivers in order to fuel lower costs for vehicles driven by their system. They've also built their system using the highest standards of safety. Jacob Langer is the CEO of Creation Labs, and he has a background in data science. He discusses in today's episode the future of Creation Labs and their impact on trucking and autonomous vehicles.
That looks better, raw.
Today's show is sponsored by StrongDM. If you're working from home, managing a gazillion SSH database passwords and Kubernetes certs is difficult. Meet StrongDM. You can manage and audit access to servers, databases, and Kubernetes clusters no matter where your employees are. With StrongDM, you can easily extend your identity provider to manage infrastructure access. Automate onboarding, offboarding, and moving people within roles with the click of a button. It's trusted by companies like Hearst, Peloton, and SoFi to manage access, so you'll have more control and less hassle. StrongDM. You can manage and audit remote access to infrastructure. Start your free trial today for 14 days at strongdm.com/sedaily. There's no credit card required. That's strongdm.com/sedaily. Thanks to StrongDM for being a sponsor. Jacob, welcome to the show.
Thank you. It's great to be here.
You work on autonomous driving, specifically autonomous trucking. It's 2021. Give me a refresher. What's the state of the art in autonomous trucking today? Where are we? How far are we from actual deployments?
Yeah, so obviously there's a number of players with different approaches, right? You can obviously see the sort of, Waymos and Embarks of the world, like trying to basically run their first kind of trial engagements. They usually still have a safety driver. I mean, that's kind of the sort of standard operating practice. So it's sort of a little bit disappointing that timeline to I think what most people believed. I think one of the specificities for us as a startup based in London is that in Europe it's arguably even much worse. There's no real focus on autonomous trucking pretty much anywhere in Europe, with basically one or the very most two exceptions, which is somewhat disappointing compared to I think the visions that we've been told. Obviously, on the technical side, there's still sort of the LiDAR versus no LiDAR debate. I think, if you look at it from a sort of less already sort of entrenched view, I think that what the correct answer shapes up to be effectively something along the lines of like LiDAR is a very useful tool. If I'm being a little bit dismissive, maybe a crutch of sorts that's probably useful in the short term, but probably not necessary in the long term. But there's this inherent conflict between the types of the types of approaches that existing players have already adopted. So we're kind of having a really strange debate, in my view, about what type of sensor to use. So I think that's kind of like sort of 10,000 feet kind of overview of autonomous trucking landscape. Happy to dive into any of those sort of major pillars.
Can you tell me about the ingest process for all the sensor data and how it gets integrated and turned into a decision?
Yeah, so effectively, there's obviously a whole like a large amount of centrifusion going on depending on what setup you have going on. Our approach has been to basically start with computer vision. I myself, as well as my co-founder, Dr. James Hennessy, we both have fairly strong backgrounds in computer vision, so we kind of thought like we're gonna leverage that to the largest extent possible. I think Tesla has demonstrated that just basically with just some combination of radar and vision, you can already have a pretty complicated, pretty sophisticated system able to navigate pretty complicated situations. I think that people watching full self-driving beta on the streets of San Francisco can kind of see how far you can get without any complicated sensor fusion and with LiDAR and many other modalities. So I think that's about as much as I can say on this topic publicly.
Can you tell me anything more about like maybe the data pipeline? Just maybe you can speak in general terms, or like some of the software infrastructure that you use to process data.
Right. So I think one of the really important components is obviously, having the full context for any particular driving decision. So I think, it is no accident that sort of Elon Musk and Andrej Karpathy speak so much about the sort of the 60 data labeling pipeline, which in essence, really what they mean by that is a pipeline that effectively understands the not just the video data sort of within for a particular object, but also is able to track that object across time, including its dimensions. So it's sort of kind of not just understands the 2D version of the image, but also implicitly understands the 3D structure behind it. And at some deep level, that's probably how humans also understand the world. We have sort of object permanence from very early age, and that's something that unless you sort of explicitly enforce in your architecture, it's probably pretty hard to get as just as an emergent behavior.
How do you feel about the competitive landscape? Because like there are companies that are really well financed, they have really large teams working on a problem like autonomous trucking. How do you stay competitive?
Yeah, great question. So I think one of the core decisions, and I think this might be sort of unique to Europe, is really understanding the regulation side of things, which is sort of the necessary function, and especially in a market where tends to be more on the conservative side, you kind of really need to sort of slowly demonstrate to the regulator that your system is safe. Traditionally, looking at automotive safety cases, the way that they have been done is basically, on this almost more deterministic fashion, meaning, you have a certain sensor, let's say radar or LiDAR, and I think that's why they've probably been favored early on, because from an automotive safety point of view, LiDAR gives you very useful guarantees about certain behaviors. I'm not going to hit something because I have a certain sort of almost first principles physics based guarantee of a particular sort of distance, and that's incredibly useful. Sure, LiDAR might degrade a lot with weather, but it's still better than sort of just trying to define a statistical safety case for vision systems only. But I think it's inevitable that anytime you incorporate a machine learning component, which at the very least for path planning is a very strict requirement, you will inevitably need to sort of have some degree of statistical components in that safety case. So safety cases typically constructed both on component level as well as on system level. So you basically have to prove to the regulator that your system as a whole is safe, and within almost no matter what happens, or to certain like statistical certainty. Now, to have data for that is a pretty long and extensive process, and as a result, it makes sense to kind of stick to simpler approaches, which is why we've started building out very incrementally, and really started to be sort of started with just a pain point that all logistics fleets have, which is fuel, and really take decisions while under supervision of the human driver, where we effectively can start gathering data on the statistical safety of our system and sort of build up from there. And in general, most of Europe has not even had the regulation drawn up for how public roads testing without a safety driver would even look like. In the UK, there's some semblance of that, but so far everyone here is tested with the safety driver. So there's sort of an interesting aspect to the way that regulation is done, which is obviously really the biggest sort of real barrier to entry. Like ultimately, it's how do you prove these systems are safe? It's probably what's held back this whole industry by so much compared to what was expected.
Can you explain the regulatory situation in more detail? Like, how specifically are regulators handling the maturity level of self-driving today?
Sure. So essentially, what I'll probably, if that's fine, I'll probably stick to the UK, which is the regulatory environment that I know best. And it's interesting because in many ways, it is kind of halfway between what US is doing and what the rest of Europe is doing in many ways. Because obviously, though at state, some of this legislation is done on a state level rather than on a federal level. But in the UK, there is even an interesting ongoing debate about how should Tesla be sort of allowed to actually run their systems, because even though they're obviously don't saying that explicitly, but there's increasing levels of automation available in especially the Tesla vehicles. And so there is now an ongoing sort of revision of the regulation around sort of automated lane keep assist systems, which is really kind of the first attempts of most OEMs to really get into anything that resembles machine learning. Tesla obviously autopilot goes far beyond the what automated lane keep assist, which is literally just a system that kind of, when it can see visible lane markings, it will keep you in the middle of the two, which is something that CMU has done in 1990s, I believe, on a prototype vehicle, with just some sort of very simple contrast-based algorithm. I think it was just some sort of gradient of the contrast at that point. It was very simple. And so that's kind of where the most deployed systems fall. Now, obviously, there's ambitions to go further. So there is a sort of code of practice for testing of automated and highly automated vehicles, that in principle allows level 4 testing within a defined, what's known as an operational design domain. Basically, you define the settings under which your system is expected to perform safely, and then you're expected to keep those boundaries. And in principle, that allows for sort of testing without a safety driver.
What's wrong with this?
So far, no one's done that yet, but in principle, that option exists. There are some further requirements on how you need to run those. So you need to have appropriate insurance. You need to have sort of appropriate data logging sort of requirements. I think not too different from what California requires. So in many ways, it's kind of similar to how California chooses to define automotive safety.
Can you say more about how your systems differ from the existing models that are out there, the existing known self-driving models?
Right. So I think we're going pure computer vision, which I think we're doing for two reasons. One, we think that you will over the end, like in the end, you will absolutely have a system that's as robust with computer vision alone. I think no human needs a LiDAR. There's no reason why a person would need that. Why any sort of driving system would need that either. At the end of the day, I think LiDAR also has many technical challenges. That it has a fairly limited range compared to cameras, and especially in the UK or throughout Europe, where rain is very much an expected occurrence, unlike in Arizona, where you can test your Waymo system and sort of without really consideration to what happens when it rains. Here you sort of have to put that into consideration. So vision is a very logical step, because it can go much further beyond that. It can have a much longer range, which especially for trucking is an important consideration, given that to stop really takes a while to stop 44 tons. And really, I think the incremental approach is something that I think to some people it can almost sound like going backward, but even the regulators are still kind of afraid of these sort of machine learning systems being deployed at scale, especially for vehicles that are sort of have the capacity to basically run through a wall. So there is sort of like another component of that. And I guess the last thing for us is that we're really trying to, rather than going with the sort of fully supervised route where you effectively kind of define every like sort of component of the driving task, we're really trying to basically use self-supervised learning as much as possible. And for the constituent tasks that we've identified so far, that is very much an option. So there's frequent jokes about some players, having almost a cone labeling person, and I think that like at the point where you need to define what a cone is, what a random piece of trash in the street is, like to explain it to the algorithm whether it matters or not. I think that is already a sort of very, you've already ended up with a system that's way too complex for anyone to really meaningfully manage and deploy. I think in the end, it's going to be no less complicated to deploy such a system than to deploy a system that's sort of self-supervised once you can prove statistical safety.
O'Reilly is known for its animal books, which have helped tech professionals stay ahead for over 40 years. Today, its online learning platform at O'Reilly.com takes learning tech to the next level. Sure, your teams get access to thousands of books and videos, but there's also interactive learning, where they can get hands-on with technology like Kubernetes, Python, Docker, Java, and more in live development environments. So they learn by doing, not just reading. With online sessions, your teams learn from the biggest brains in AI, software architecture, cloud, data, programming, and more. They can even prep for tech certification exams with office materials and interactive practice tests. And then there's O'Reilly Answers. You just ask an NLP search engine any tech question, and it takes you right to the best answers from O'Reilly's renowned books. That's why 66% of all Fortune 100 companies give their teams O'Reilly Online Learning. Get a demo today at O'Reilly.com. That's O'Reilly.com. You've mentioned self-supervised learning, I think. Is that the term you used?
Mm-hmm.
Can you describe what self-supervised learning is?
Right. So self-supervised learning is really where there's a way to define the data as effectively the label for itself, right? So in our case, it's basically meaning you can define to sort of the human behavior as what the human actually ended up doing as the correct label. Whereas as opposed to a traditional paradigm where you basically kind of have a human annotator define every component, it comes with its own challenges for being able to run a system like that. But unfortunately, I cannot go into those right now.
You are somebody who's deeply familiar with generative adversarial networks. Are GANs at all useful in self-driving?
Yeah, so I think GANs are absolutely useful in a couple of constituent components. One application that I'm still very excited about, and I think I just wish I could do a bit more of, is effectively generative domain adaptation. So I think absolutely every single company that we know of doing self-driving has at some point trained in simulation. I think one major issue with simulation is the lack of perceptual realism. Obviously we have now a sort of attempts at photorealism through sort of render sequences that still take way too long to be practically usable. And really what you want when you're training in simulation is to do exactly what you cannot do in the real world, which is to run that simulation million times a second with the version of an agent, and then basically sort of do gradient averaging against all those possibilities. So the way that we solve this perceptual realism issue is we use something known as generative domain adaptation, which really sort of borrows from approaches like CycleGAN, where we effectively take the sort of simulated domain and the real domain, and we basically ask the generative model to translate the simulated into the real. One of the magic things about this approach is that this works even without sort of any sort of paired domains. So you just take a bunch of sort of simulated images and a bunch of real images, and the system effectively learns what the correct sort of transformation is. So if anyone's familiar with the technique called style transfer, you can almost think of it as a learned style transfer, where you basically define the sort of synthetic style and realism style, and CycleGAN almost learns how to transform one into the other. So that's kind of the high level. More than happy to go into more of the technical detail of how that works, but hopefully that makes sense.
I would like to hear you go a little bit deeper into the implementation.
Sure. So essentially, I think let's just do a super quick refresher of what a GAN is. So GAN effectively is a generative adversarial networks. So if you break it down, you basically have two networks, one called the generator, one called the discriminator. And basically they're adversarial because they compete against each other. So in the original paper, the loss function of the generators is literally just the inverse of the discriminator's loss function. Later on, that got revised, but effectively,
I like
it
that.
is two networks where they one of them sort of wins and the other one has to lose. So you can almost think about it as like a very adversarial relationship between a student painter and a teacher painter, where the teacher is trying to identify what paintings are good, and the student painter is trying to produce paintings, which is basically what the generator does, and the discriminator is basically trying to tell what is real and what is fake. So that's the sort of super quick rundown of what a GAN is. Now, there's a more advanced architecture that came around in about 2016, 2017 called CycleGAN, which was very, it instantly became very popular because of the magic of what you could do with it, where effectively you now have a much more complicated architecture of four neural networks that effectively act as a sort of generators between two different domains and discriminators for those respective domains. So what that means is you effectively train one generator to not create an image from scratch, but just do basically a rendition of that painting in another style. So you can think about it as like, here's a Van Gogh picture, and now make it a Da Vinci picture or something like that.
Okay, that looks fun to me.
So and sort of the same way the other way around. So you basically have a one painter that does from A to B, and then another painter does from B to A, and at every point there's a critic that effectively evaluates the realism of that picture. And because you can translate it twice, right? So go A to B and then B to A, you effectively define what's known as a cyclical loss. So you can almost think of it as translating a sentence from English to French and then from French to English, and then measuring the difference. And so that way you effectively get a sort of loss function where you can, even without having sort of irrelevant labels in the other domain, you can sort of define a meaningful mappings in both directions from A to B and B to A. So that constitutes CycleGAN. And effectively now the task just becomes, how do I translate synthetic labels or synthetic images to real images and then back again.
So now that we have a little bit of an understanding of some of the infrastructure and the algorithms that you're working with, tell me about the state of the art for building autonomous driving technology. Like, what kinds of cloud services are you using? What kinds of machine learning frameworks you're using? Just tell me about the general stack.
Yeah, I mean, I think I think in tech you're kind of always told as an engineer to use boring technology for anything that you're not innovating on. So being a fairly small and agile company, that's exactly what we're doing. So AWS is probably the easiest way to get started, and obviously one of the sort of intelligent things is once you know how the AWS ecosystem works, you tend to use it. So I think that their marketing strategy or definitely worked there. So that's what we use. And then on the like framework side, like I think there's this kind of ongoing debate of sorts of between TensorFlow versus PyTorch. We definitely lean heavily towards PyTorch. I think I've personally just, I think I made the switch about 3 years ago, and I just personally found it much easier to work with on almost every level. So that's kind of on the high level stack. And then obviously, once you start putting this into embedded systems, you have to do a bit of transformations through like standard things like Onyx, which is a framework for basically defining, I think, interoperable or interportable kind of networks that can be basically put on a much less powerful compute than you'd find on a massive box in the cloud, because that's obviously convenient for training and training time. You can have as much compute as you want, but at inference time, you really want to make sure that it's fairly limited in terms of the number of operations that it needs to run. So that's also a design consideration when you're running the neural networks. And I think a slight tangent, I think one of the reasons why Tesla has an interesting approach with the sort of the designing their own self-driving chip. And I think in principle, I think for a lot of other players, NVIDIA has such a strong grasp on the market, because really once you cross certain threshold, your options are either making your own or using NVIDIA. And obviously most people just choose to go the simple thing and use NVIDIA. Tesla designed their own. And I think that is still an interestingly sort of underserved market in terms of like just the sheer chip dominance that with just a handful of global players.
Panther is a cloud-native security analytics company built by a veteran team of security practitioners from high-tech companies like Airbnb and Amazon. They're helping to address modern security challenges. Go cloud native. There are two things that any growing organization needs: speed and scale. You can analyze all of your critical security data with no overhead or extra infrastructure required. Panther gives you security as code. Give your team the power of security as code with Python detections and developer-friendly workflows for finding threats fast and easy. There's open data. You can leverage existing BI tools like Tableau, Qlik, and more to build advanced security reports, metrics, and visualizations with zero-copy data transfer. Security for business speed and scale. The cloud-native security analytics platform designed by Panther alleviates the pain of traditional security products. Panther is built for speed, flexibility, customization, and petabyte scale. You get real-time alerts with Python detections, security automation, and you can bootstrap your security data lake, all
Did you
using
just say
Panther.
Python detections?
Process and normalize data from across your environment to build a scalable security data lake in AWS or Snowflake that grows with your business. Check out Panther at runpanther.io/sedaily and learn about a modern security platform that can grow with your needs. That's runpanther.io/sedaily. Could you go into the dynamics between TensorFlow and PyTorch a little bit more? You said you prefer PyTorch at this point, right?
Yeah, I mean, I think when TensorFlow came out, was it 2015, 2016 maybe, something like that. I think, I sort of started trying to work with it, and it became very apparent that this was kind of a system that was really designed for internal use at Google. I mean, obviously Google ships TensorFlow, but doesn't ship all of the support framework. I mean, they've open sourced more of it over the years, but initially it was very like sort of standalone, sort of kind of try your own luck. And I think when you look into the sort of design considerations that TensorFlow has built out, I think it's been really a system that has been sort of optimized for production from day one. But I don't know if in hindsight that was the right call, because the sort of choices, the design choices that TensorFlow has made always made it sort of run relatively well at Google scale, but not so well for anyone else, and especially not for people just getting familiar with the framework. I remember the error messages that you got in the beginning were completely unintelligible. But I mean, obviously, to Google's credit, they absolutely got miles better. But I just think that attitude of sort of optimizing for the sort of almost internal Google production use case has never really gone away. Whereas PyTorch, I think, has been sort of making, I think, intelligent decisions around, like, we still kind of want almost I don't think it's unfair to say, I think it almost under prioritized production use in the early days, but it made it very user friendly. One of the things that I think improves everyone's
How is this supposed to
productivity,
work?
and then it's sort of almost the taboo of some machine learning, but it's like just being able to use debuggers well. It's such a simple thing in most of software engineering, but in machine learning, really, there's so many people that either don't even know that debuggers exist, or are very sort of hesitant to use them. I think it's such a speed up to anyone's productivity, and you almost cannot use it with any debugger with TensorFlow, because it sort of, especially historically, it had this sort of awkward sort of graph definition step and then execution step. And then if you wanted to see the interaction, you had to keep rerunning the program to understand what the problem was. Whereas with PyTorch, you can all sort of put in a breakpoint anywhere and just jump straight to that point, which is always such a massive improvement. I think that really sort of won me over. And then I think over time, PyTorch again did sort of they started converging closer together, because PyTorch started building more towards production. They introduced things like TorchScript that allow you to basically precompile parts of the graph and make it more performant and make it sort of easier to use on other chips and so on. So there's definitely been an interesting degree of convergence between the two, but I think PyTorch is kind of like it's easier to pick up to this day and easier to debug. And I think really, if we all like put ourselves to sort of human level, like that always speeds up your rate of iteration, and that's really what matters.
Do you have a testing loop for how you test and gather the data on self-driving trucks?
Yeah, so we're in the process of sort of building a more sophisticated version of that. But of course, having a testing loop is incredibly important. I think there's a number of things you can do. Obviously, simulation is a very useful component of it, because not only gives you ability to obviously train new algorithms and explore a little bit more sort of ambitious variations than you might do in the real world, but also it allows you to check that your performance still holds across certain scenarios. One of the things people frequently talk about is edge cases, and you can sort of test that your algorithm runs against well-defined edge cases. There's even a whole set of industry standards on defining the position of certain objects, vehicle, the road conditions, and so on, which then constitute a safety case. Sort of, it's not quite a safety case, it's not quite true, but it's essentially a definition of sort of edge case that your algorithm needs to clear. It comes from sort of safety engineering world, where basically you use these kind of like scenarios where your algorithm broke down or where your procedure broke down, and then you basically try to make sure that never happens again. So basically, in many ways, that becomes a very important part of your CI/CD. So there's obviously elements you can do like that. I mean, at the same time, there's obviously sort of the difference between like software in the loop and hardware in the loop sort of behavior. So you need to make sure that you're really kind of testing against both. And obviously, nothing's going to be as scalable as pure software. So you need to be a little bit more intelligent about when you're doing sort of new releases, like how do you test against the defined pre-existing sort of real world scenarios, and do you go out and do you test new scenarios with your new model or not, depending on how do you make that decision. So I think there's a lot of important pieces that kind of really break down just the traditional software barrier, where you really need to think about the sort of real world behavior, which for a lot of software you don't really have to think about too much. It's just an extra layer of complication.
What are some of the problems that you've encountered in productionizing real world machine learning?
Yeah, good question. I mean, I think every time I've deployed a machine learning system into production, there's always been, at least, even though you think you thought about everything, there's always something that you've missed, which is why people do testing. I'm trying to think if there's like any sort of general kind of rules. I mean, there's there's all sorts of, especially when you're defining sort of the model parameters across to sort of correspond to a particular vehicle. There's always a sort of interesting drifts that happen that depending on sort of the weight and the weight distribution of the vehicle, that can cause quite a complication. I mean, I think in general, like I think at the end of the day, it's always really important to have a really rigorous testing process. Sort of starting out with sort of unit testing of the most basic behavior in your software that ensures the safety code is running as it should, all the way up to basically the more complicated scenarios. I mean, in simple machine learning models before in my sort of past life, I think the challenges there, in principle, were always pretty similar, except of course now that the magnitude and the level of impact is much higher. But there's all the standard problems of like model drift, monitoring models in production. It can be quite difficult for some things to ensure that in no edge case has your model performance degraded to some bizarre equilibrium. I think that just takes a lot of kind of thoughtful work.
So your company is Creation Labs. Is it a company? Is it a experimentation center? What exactly are you doing at Creation Labs?
So it is absolutely a company, but I think that we're really trying to basically kind of come up with a new approach to autonomy that in some ways ironically is a little bit more conservative, but we also think we can provide more value faster. I think one of the really interesting components is that you can deliver value to fleets, whether that's sort of fuel and carbon reduction or sort of safety analysis of the sort of machine augmented human drivers. And I think that's one of the things that I think ultimately, especially in Europe, will probably take the cake, because I think in general regulators like to see kind of very careful and disciplined deployment. And that's really what we're doing. So we're basically working with logistics companies to provide them basically initially with sort of very very low levels of automation and sort of increasing that over time. So we're already working on effectively improving on sort of longitudinal control of vehicles. So effectively, how fast you're going, how do you do that more fuel efficiently, how do you do that more safely, and that's already something that if you can fit to vehicles that even
Why are there
vehicles
two?
today rolling off production line frequently have absolutely no intelligence embedded in them as a default. I mean, a lot of the OEMs now start to provide additional add-ons, but those are obviously only available at sort of at purchase decision. So most of the trucks driving on the road today and for the foreseeable future
Why are
are
there
fairly
two?
dumb trucks.
Why is there a
And
request
being
cash
able
out
to
and then a
basically go
payout?
in and retrofit some layer of intelligence can already provide a lot of value. And we think that incrementally we can take over more and more of the value chain, and ultimately sort of start delivering sort of a level 4 systems that can, just based
Oh
on the
God.
statistical safety that we've proven out with the lower levels of automation, are roadworthy.
Demand for on prem software remains enormous. It continues to grow and it's not going away. Take advantage of the automation, reliability patterns, and primitives provided by Kubernetes for not only your applications, but also in how your on prem and multi prem apps are delivered and managed. Kubernetes and other cloud native technologies have led the way to modernizing on prem software delivery. It no longer has to be a tarball and a 150-page manual. Go to replicated.com/sedaily to learn how Replicated can help you modernize your on-prem software delivery strategy. If you're a software vendor looking to modernize your application delivery and management to gain more enterprise adoption, check out replicated.com/sedaily. Replicated gives software vendors a container-based platform for easily deploying cloud-native applications inside customers' environments to provide greater security and control. So check out replicated.com/sedaily and learn how to deliver and manage your software through all kinds of methods. Bare metal servers, cloud VPC, GovCloud, even air-gapped. There's a secure way that your customers can use your application without ever having to send data outside of their control. And Replicated is already trusted by noteworthy customers like HashiCorp, CircleCI, and SNCC. Go to replicated.com/sedaily to get a free 21-day trial of the full Replicated platform. Can you tell me a little bit more about the integration of hardware and software? How do you get the trucks like driving using the software that you've written, and what's the integration stack look like?
Yeah, so right now we operate with a select number of vehicles for like the sort of full, sort of quote unquote full level 2 system. So there we sort of have a defined control model that we basically largely leverage the existing hardware, and we basically leverage the EPS and sort of the internal CAN messaging to basically control lateral and longitudinal control. When there is a sort of lower level of automation product, which is basically just kind of a computer vision based sort of better cruise control, which only then has sort of one integration point and has a sort of lower safety case requirement, but at the same time effectively manages to sort of just integrate fairly simply into the control systems. So trucks especially have a sort of extra layer of standardization, unlike regular vehicles, which is a protocol known as J1939, which effectively sits on top of the CAN protocol, and that effectively provides a layer of standardization. It is still somewhat flexible. There are still OEM-specific fields, but largely, but there's a great amount of sort of standard behavior. So we use that as a sort of the lower level of automation, and then we have a higher level of automated systems for select number of vehicles.
Do you have a perspective on whether there will be a strong lead by the companies that build their own hardware and have the stack fully integrated, like a Tesla, versus some sort of partnership or amalgamation of different companies, like some sort of supply chain partnership?
Yeah, it's a good question. I do think in the personal car space, I think, in terms of like mass deployment, and that's part of the reason why we think incrementality makes so much sense. And it's kind of, in a sense, is also what Tesla did, is, just a variety of edge cases that you can sort of the long tail you can capture in the real world. But ironically, I think like Tesla is like the lead for like the mass adoption of sort of L4 and maybe eventually L5 self-driving, largely not because necessarily that they have been building the cars from scratch, but because they can sort of collect all that data and sort of source new interesting cases on a basically weekly, hourly basis, which is something that is so invaluable when building out systems that have to deal with all sorts of weird scenarios. I think it's in principle, like the Waymo approach or so many other players, I think Jaguar R-Pace seems to be a very popular vehicle to integrate with. It's a good car, and obviously the approaches that people have chosen so far have been very restricted. But I think there's a real question, and I think, obviously, people from Waymo and et cetera will disagree, but I think there's a real question about how well this can scale. I think first and foremost, as a machine learning engineer, I'm worried about the sort of ability of that system to solve cases where, everything looks so different. And, the sort of, even for sensors that are sort of less sensitive to the visual side, like LiDAR, I think that you still need the sort of out of distribution behavior is still needs to be validated. And, every time you deploy to a new area, and that could be as little as like the next state, right? It's like you're running into real questions about will this system work as well as it did in the previous state. And I think it gets much worse, across continents or across countries, even between just like Germany and France. Is like very hard to imagine how those the two systems will scale just with the approach that Waymo has taken.
Well, just to wrap up, do you have any other thoughts on the future of self-driving and where we're going?
Yeah, I mean, I do think that it is still an exciting area. Like innovation is going, and I think that the one funny thing that I think that sort of applies very accurately. I think there's this concept of like the Gartner hype cycle, and I do think that we're definitely past the peak hype, and I think we're slowly getting into sort of through the I think it's like the trough of disillusionment or whatever it's called, and then there's the plateau of proactivity. So I think we're slowly getting there, and I do think that it is still one of the most impactful transformational sort of applications of computer vision and machine learning. I think a lot of machine learning and AI has so far been really sort of more as a sort of filtering step of some kind. And I think these are like the first big real production systems that are starting to basically leverage machine learning that make a difference in like everyone's lives. So I do think there's a sort of still like much excitement ahead as we sort of build out these systems and kind of bring them to every country around the world. I think there's an interesting kind of still set of hurdles yet to overcome. I think we're probably still a good number of years away from sort of full level 4 self-driving for any type of vehicle. I think maybe there's a non-zero chance that the full self-driving beta that's currently out there will not hit another plateau. I suppose that is possible. My expectation is that more likely than not it will. At which point, sort of some areas of US might start seeing level 4 self-driving in personal cars within this 1 or 2 years. I still think it's highly likely that it will hit another plateau. And for everyone else, I do think that it'll take a lot while longer. And then I think in Europe, it almost doesn't matter who you are. You will need to prove out statistical safety over a long period of time, because ultimately the problem with edge cases is that accidents happen very rarely, thankfully. But you still need to show that on a large enough sample that you're performing better than humans or at least comparable. And so there's still a long journey there to demonstrate that in every country on their data on their turf, which I think will mostly be the requirement. So, but I do think it's an exciting world ahead, and I think there's still so much to be done.
Okay, well, Jacob, thanks for coming on the show. It's been great talking.
All right, thank you for having me.
Oh, how does it say pay bounties? Oh. What does that even mean? Courier delivered receipt. Where's there a courier delivered receipt at? Oh, hold up. Isn't that paid a delete, a receipt? Delivery. There's a delivery receipt. Delivery receipt is different from a courier delivered receipt. Apparently. What's the difference? Is a courier ID. Hold up. What is the difference? Courier ID? Oh, the to account. That's the difference. Okay. We'll throw it as a private. So we'll say let private to courier delivered receipt. Paid. Or it's not paid. Okay. Not paid, but it's really a delivery receipt, right? Like that. And we want it to be a courier delivered receipt, which means that we take this. Okay. And we are going to say that delivered ID equals v dot delivered ID. Courier ID equals v dot. It should be delivered dot. Where's courier at? How does a delivery receipt not have a courier attached to it? V dot delivered. There's a bounty. There's pickups. All right, so I have a courier ID on here. Okay. delivered equals v dot delivered. That should be straight. And we just say v dot timestamp. And that's it. Okay. So then we have this request.uncollected to query delivered receipt. We'll say sequence.map function goes to courier delivered receipt. And then we have the V, and then we have the request courier ID like that. That should be fine. Okay. So, I mean, or we could just say courier delivered receipts. And we can place that up here. Let courier I need to say let delivered receipts. That I mean, what stops me from just saying receipts? Okay. I would argue that we don't even need courier ID in here because these receipts are already included. All right. I mean, that's what I would argue. That's what I would argue. You already have your delivery ID. No, you don't. What is this? Pickups. I guess not. I'll take that back. I'll take that back. But what was the point of me saying to courier delivered receipts if that's not it? Like, I don't understand. Hold up. Courier delivered receipt delivered does not have a courier attached to it. Yes, it does. Courier delivered receipt. I'm getting lost, man. Does delivered already have a reference to courier ID? No, it doesn't. Okay. What's the other errors that I have? It's uncollected goes right here. Courier ID, uncollected into account. So then the other question is, why do I have a request cash out and also have a payout in here? I don't understand why do I have two operations that look like they're doing the same thing? Does this request receipts have anything? Why do I have all this in here? They're not doing anything. Request receipt. Is that used anywhere? Yeah. All right, cool. Uncollected deliveries should be used somewhere. Are you? Nope, it's not being used. Okay. Destination account. I know you're being used. You have to. You're the last thing that I added. And that's being used. Okay. Request receipt. I forget. Did I ask for this already? I feel like I already did. Yep. Verify not paid. Are you being used? Hold up. Verify not paid. Are you being used? Yep, you're being used. Can't compensate. Are you being used? It looks like it's being used. Okay. Task result. I don't even know what all accounts is. I can almost promise all accounts isn't. What is this? That's probably for the admin. Okay. Create account and get status. Okay. Tell me what it is about the dog. Give me life, forgive me death, and breath, and hold my breath. Oh, no, I'm gonna die every day. Sold my soul to the devil. The price is cheap. All right, I'm butchering all this. So what did I accomplish? We have this cash out receipt that we now have. I think this payout receipt can be removed. I have this cash out receipt. And so this is from a courier payroll service, which means that our beach delivery courier service should now be able to have a cash out receipt. Okay. What is it about the dog? Okay, so let's say update it. That. And then for the career payroll, say cash out receipt support. And I am taking a break. So I'm out. See ya. Bye.